But factorial, so we're going to do factorial and sigma notation today. Factorial is not brand new to you. I know for sure you did it because you did it in geometry. And I gave you pretty much these same words at that point. So factorial is the factorial of a number is that number multiplied by every positive integer before it. Okay, it's multiplied by every positive integer before it. Factorial notation is indicated by what symbol? The exclamation point. Okay, and I'm pretty sure that, I mean, this is something that I think that you had seen even before geometry. I don't know how much you did with it, but so if I have this, it's not an excited n, right? This reads n, oh, not e, goodness, n factorial. Okay, n factorial. So in the order of operations, your order of operations, please excuse my dear Aunt Sally, right? Factorials have equal importance to exponents. So they have equal importance to exponents. Therefore, the only thing with more importance than factorials is what? Parentheses. Yeah, parentheses. All right, so if I have n factorial, what this means is I'm going to multiply n times n minus 1 times n minus 2 all the way down to 3 times 2 times 1. It's every positive integer before it. You cannot evaluate 3.5 factorial. That doesn't make any sense. It's all about integers. What is 0 factorial? You know? It's not 0, it is 1. Okay? And if you think about factorial, one of the things that you use factorial for is arrangements of things. So if I have 3 people in line, right? So then there's 3 spots in the line, right? So the first person in line could be 3 different people, but once that person's there, then only have 2 people left to put in line, then I just have 1. So 3 times 2 times 1, there are 6 different arrangements that could be made. Does that make sense to you? If there's only 2 people in line, then there's just 2 arrangements. If there's only 1 person in line, there's only 1 possible way to arrange it, that 1 person. But when there's 0, there's only 1 possible way to arrange that too, and that you can't. That's one way to look at it. There's different ways to explain why it is 1. But one of the things that I read said, if for no other reason, it's because mathematicians decided to define it that way. But 0 factorial is 1. It's not 0. So don't go, dividing things or canceling things out because you're thinking you're multiplying by 0. All right, so 5 factorial. This just means 5 times what? 4 times 3 times 2 times 1. So 5 times 4 is 20, times 3 is 60, times 2 is 120. Okay. Then when you have this, now I could multiply out the entire numerator, multiply out the entire denominator, or I could use it on the calculator, but for the rest of the factorials, we're not touching the calculator. I'll let you get the calculator for the sigma stuff that we're doing. You need to know how to handle these without a calculator as well. So if you have a fraction, you start with the bigger factorial. So the bigger one, obviously, is this 10. So I'm going to expand it 10 times 9 times 8 times 7. You expand it until you can match the denominator. And I can stop with 7 factorial. Because that means 7 times 6 times 5 times 4, but I don't need to multiply it all out. All over 7 factorial. So then can I reduce this? Yes, I can knock those out. And I get 10 times 9 times 8. That's 72 times 10, which is 720. All right, so then I have this. If I'm multiplying the 2, I do not get 42 factorial. You cannot do that. Remember, order of operations, you have to do that, to do the factorial before the multiplication. But I also don't want to multiply all that stuff out. So once again, I start with the biggest one, which is 12, and I'm going to expand it until I can match the biggest one in the denominator. So this is going to be 12 times 11 times 10 times 9 times 8 times 7 factorial, all over 7 factorial, 6 factorial. Can I reduce that? Yes, I can knock out the 7 factorials, right? Now, I can't expand the numerator to match the denominator anymore because it doesn't. So I need to rewrite the numerator and expand the denominator. 6 times 5 times 4. And I don't really need the 1 there. Now, if this is a non-calculator question, you should be able to handle this. Do I actually want to multiply all that stuff together? No. I can take 6 goes into 12 how many times? Twice. So I'm going to change that to a 2. 5 goes into 10 twice. 4 goes into 8 twice. 3 goes into 9 3 times. And then don't forget your 11 here because it kind of gets hidden in all your junk. And then the 2, I can just knock out one of the 2's right there. Sometimes you lose things in your own work, right? So 2 times 11 times 2 times 3. So this gives me 2 times 3, which is 6, times 2, which is 12. What's 12 times 11? 132. I know, it's the hard question of the day. It's Monday. All right, so the next 2 look similar to what I just showed you on that worksheet on Friday, just to see how much of the factorial you even remembered. Obviously, I do not have enough information to solve for x. It doesn't ask me to solve. It's not an equation anyway. It's just an expression, so I couldn't solve it if I wanted to. But you still do the same thing we did on the other ones, is you take the larger one. So which one's larger, the numerator or denominator? The numerator, because x has to be a positive integer for this to work. So the numerator has to be bigger. So I expand the numerator until I can match the denominator. So it's x plus 2, and then the one before it is x plus 1. And then the one before that is x, and that matches my denominator. I can cancel those out. So that leaves me with x plus 2 times x plus 1. And then that's going to give me x squared plus 3x plus 2. Okay, everybody okay with that? On this one, which one's bigger? The denominator, right? So this is going to, the numerator stays x minus 1. Denominator becomes x plus 1 times what? X times x minus 1. Now that matches, because I have no idea what x is. Those cancel out. So does it just leave me with x plus 1 times x? 1 over. 1 over x plus 1 times x, which is 1 over x squared plus x. Okay, bless you. Everybody okay with that? Can handle that? All right. So now let's look at sigma notation, which again I just kind of showed you quickly. But so a series, okay, remember there's a difference between your sequences and series. A series can be written in abbreviated form by using the Greek letter sigma, called the summation sign, so it can also be called summation notation. N is the index of summation. Okay, so N means that's these two would match right here. And then K is the upper bound, 1 is the lower bound. So this is your lower bound of your series, this is your upper bound, whatever you're going to substitute in to figure out your terms. Okay? There's 2 different things that you can do with these. You can expand them and evaluate them, and we're going to do both. Put your phone away. Okay, so expanding first, because it says expand and then evaluate. So we're going to expand this one. Expanding basically means we're going to substitute this in. N is 1 all the way to 5. So I just substituted in 6 minus 3 times 1 plus 6 minus 3 times 2 plus 6 minus 3 times 3 plus 6 minus 3 times 4 plus 6 minus 3 times 5. This is expanding it, not just evaluating it. Okay? And so once we do this, this is 6 minus 3. What does that give me? 3. Plus, this is 6 minus 6, which is 0. Plus, 6 minus 9 is negative 3. So instead of plus, I can actually put minus. Oh, why does it change colors? Minus 3. And then 6 minus 12 is negative 6. And then 6 minus 15 is negative 9. So this is expanded. Remember, your series is the adding of your sequences. So that's the expanded form. Then to evaluate means we're going to find the sum. Well, it's already expanded for me. So 3 minus 3 is 0, and then negative 6 and negative 9 gives me what? Negative 15. And there is the evaluated version. Everybody okay with that? All right. So now this one just asks me to evaluate. Well, this n goes from 1 to 35. I do not want to have to write out 35 terms. I know how this starts because it's the same as number 1. I know this starts with 3 plus 0 minus 3 minus 6 minus 9, all the way to whatever it is when n is 35. Do I have to find all of those terms and actually add them up? No. I have a little formula for that, right? Is this an arithmetic or a geometric series? Do I have a constant difference or a constant ratio? It's arithmetic. So this is arithmetic, which means that your sum, it is n times a sub 1 plus a sub n all over 2. So I could use this one, or I could use the one where I don't know the last term, but can I find the last term? Yes, because my last term isn't infinity. I've got that 35, right? So couldn't I just do 6 minus 3 times 35? And then the 35th term would be what? It's negative 3. What's 3 times 35? It's 105, and that's a negative. So then when I add 6, I get negative 99. Right? This is minus 99. So there's I got my first term and my last term. Bless you. What is n here? How many terms do I have? 35. Okay. So n is 35. I want the sum of the 35 terms. So n is 35, right, times 3 plus a negative 99 or minus 99, either way, all over 2. Yes, sir? Yes, because what this is saying is that n goes from 1 to 35. Okay, so the n being the how many terms we actually have is your 35. Okay, that's a good question. Anything else? You can go ahead and use your calculator for that one. Even though you should be capable of figuring it out without the calculator, go ahead and do that. And what do we get? Negative 1680. Okay, we all good? All right. So let's look at the next one. Okay, so we're going to evaluate this one. We're actually going to expand and evaluate this one. So we'll do expand and evaluate. That's what I should have said. So this is equal to, now notice n starts at 3. It doesn't start at 1. That's okay. So this is going to give me 2 times 3 to the 3 minus 1, which is 2 power, plus 2 times 3 to the 3rd, plus 2 times 3 to the 4th, plus 2 times 3 to the 5th, 2 times 3 to the 6th. So 2 times 9 is 18. 3 cubed is 27 times 2 is 54. Good. Plus Why isn't it 7? Because it's n minus 1. So I substitute in 7. N minus 1 gives me 6. All right, so what comes after 54? 162. What comes after 162? 486. And then, oh, that equals then 1458. Isn't each term just being multiplied by what? 3. 3 times 18 is 54. 3 times 54 is 162, right? What kind of sequence or series is this? Geometric. Okay. So when you add all that up, what do you get? 2178. Okay. So this is geometric, right? I could just find the first and last term and use my little sum, right? So if it's geometric, you have a sub 1 times 1 minus r to the n. Actually, I just need the first term. Over 1 minus r. You need the first term, you need your r, and you need your n. What is the r going to be when I look at this? R is always the base of the exponent. That's why we're multiplying each successive term by 3. Does that make sense to you? R is 3. What is n? How many terms do I have? It's not 7. We have 5. I mean, you can count them. We went from 3 to 7, right? Because this is 3 minus 1 right here, and this is 7 minus 1. And there's 5 terms. So I didn't start at 1, right? When I started at 1 to 35, there was 35 terms. But if I take 35 and subtract 1, I get 34. If I take 7 and I subtract 1, I'm sorry, if I take 7 and subtract 3, I get 4, but there are 5 terms, right? So your n for this right here, this n is always going to be the top number minus the bottom number plus 1. I guess those look like plus signs. So that is 7 minus 3 plus 1. That's where your 5 comes from. Now we know that for sure because we can count those. But if you don't want to have to write them out and count them, you want to make sure your n is correct. Or if you just jump to this formula, it's not going to work out so well for you. But all I had to do was find the first term, which I have. I can say the sum of the 5 terms that I want is the first term, which is 18, times 1 minus r is my 3, 3 to the 5th, all over 1 minus 3. And if you put that in your calculator, go ahead and do that. See what you get. What do you get? 2178. Get the same number, right? So whether you choose to use this formula or you choose to expand it, you'll get the same thing. I would not suggest that you choose to expand it if your n is going to be some crazy huge number. You with me on that? Y'all good? Did you get something weird? No, you're good. Okay, just making sure. I know. And again, simplifying it a tiny bit for yourself can help sometimes when you have fractions and whatever else. You know this is going to be a negative 2, right? And 18 divided by a negative 2 is going to give you a negative 9. So you could find this and then multiply it by a negative 9. Just be careful when you're simplifying those things for yourself that you don't make some ridiculous mistake that's going to mess you up. All right, so again, we're going to expand and evaluate this one. All right, so n goes from 1 to 5. So I substitute in the 1. It's going to give me 96 times 1/2 to the 1 minus 1, which is 0 power, plus 96 times 1/2 to the 2 minus 1, which is 1 first power, Okay, and then that pattern just continues. All right, what's anything to the 0 power? 1. So this is just 96 times 1, which is just 96. This is 96 times 1/2, which is what? 48. My r is 1/2, so what's the next term without me worrying about what this says right here? 24. And then what? 12. And then what? 6. Because each term is being multiplied by 1/2 or divided by 2. Every time you just get one more 1/2 in there. So when you add all those up, what do you get? $186. Okay. Everybody okay with that? We're not going to do that one the other way too, because I don't think we need to. If you have that few of terms, maybe writing it out, even if you don't write all this stuff out, you can get this going and figure out what you need. Now, for this one, you may not want to write them all out, right? Here's what we do know. We do know that it starts out with 96 plus 48 plus 24, because we did that up there, right? But I would like my last term so that I can use my little formula, which means I need to go find the 15th term. That's going to give me 96 times 1/2 to what power? The 14th power. And we want it as a fraction, not as a decimal. And what do we get? 3 over 512. Oh. So I actually need my last term. What kind, is this geometric or arithmetic? Geometric. So do you need your last term for geometric? No, you don't even need it. But that's okay. Wanted you to have it on there anyway. Because you could find it, and you could find all the ones in between if you want to. But having that on the end, pretty good chances. Are you going to get a whole number here? Probably not if you're adding weird fractions like that. So what is my n here? Remember, it's the top minus the bottom plus 1, so it's 15. And if you start at 1, I mean, it's 15. So the sum of those 15 terms is going to be n, which is 15, times 1 minus, what's r? 1/2 to the 15th power, all over, oh, I put it all over 2. Dang it. Now it stop me. It's geometric. So it's 1 minus r. 1 minus 1/2. I'll let you use the calculator for that one. You get something really weird, I'll just tell you. So, but yeah, I know it makes you second guess yourself. I guess even as a fraction, you're used to fractions, you're like, that one's just weird, right? What do you get for the numerator? 98,301 over what? 512. Okay. So notice you have the same denominator here. Okay, and I mean, this told me I'm pretty much going to get a fraction. I know you still didn't expect something wild and crazy like that. But here, though, we can find our last term. We may not have needed it, but I could have found it. I could find all 15 terms if I wanted to. I don't want to, but I could. On this one, if I want this sum, can I find my last term? No, because it goes to infinity, right? I can't, if I substitute that in, I can't actually find that. Now, can we find an infinite sum? Yes, we can. What has to be true in order for that to be able to happen? Yeah, the absolute value of r has to be less than 1, right? And so we've got that right there. we know that it starts off as 96 plus 48 plus 24 plus, and then I don't know what, but I can't find the infinite term, right? But the sum, notice there's no n, is just the first term over 1 minus r. These are usually pretty simple. The first term is 96 over 1 minus 1/2. What's 1 minus 1/2? 1/2. What is 96 divided by 1/2 really? What do? Multiply. It's 96 times 2, and that gives you 192. Okay. Here, even though we didn't need it, we can find it. Here, we can't find the last term. Okay? You have to have that, well, you don't have to have the last term for the arithmetic because you could use the other formula, but sometimes it's just easier to know one formula and do it that way. All right, any questions? You good? So same stuff, really, just a different way of notating the sum, but still the same formulas for your sums and whatnot. Are we good? Any questions? Awesome.